Hello there, welcome to Meet Private High School online class. In this class I am going to explain some remaining topics of 11th grade physics. And today's first topic is Hooke's law. Hooke was the scientist who studied the properties of springs for the first time, and he gave his law in the field of physics. His law says that the magnitude of stretch or compression of a spring will be directly proportional to applied force. It means that if we apply more force, obviously the magnitude of stretch or compression of spring will be more. If we apply less force, then the magnitude of stretch will be less. As you see here, we have doubled the force, stretch also doubled. We have tripled the force, magnitude of stretch also tripled. It can be applied in the case of compression force also. If we apply compressive force, then the magnitude of compression of spring will be directly proportional to magnitude of force. Okay, so how we can calculate now here a magnitude of applied force? Magnitude of applied force is simply calculated using this formula. F external is equal to K into X. What is X here? X is the magnitude of stretch. You see here, initially magnitude of stretch was 0. You see, after applying this amount of force, spring stretched this much. So X is here magnitude of stretch. Now if we apply force on springs, obviously spring reacts. Okay, how much force it will apply? This much force. You see, restoring force of spring is equal to minus K into X. K is spring constant, in which its unit is Newton by meter, and it depends on the type of spring, on the material of spring. Okay, and if, as we said, if we apply one external force on the spring, spring also acts towards the equilibrium position. Okay, these are some informations related to Hooke's law. I hope it's clear. Now let's solve one example related to Hooke's law. Example number 6, calculate the mass of the object in kilogram. Okay, you see here one spring is there and a mass is hanging. Then how much will be the mass of object in order to stretch the spring by 30 centimeter? Okay, to stretch this spring by 30 centimeter, how much mass we should hang here? Okay, here we just use that simple formula we just studied. You know, force is equal to K times X. This was the Hooke's law. Now what is force here? Here the force is gravitational force, the force which Earth is acting on this mass. How much force Earth is acting? How much force Earth is applying on this mass? Okay, that is M times G. This much of force is applied by Earth on this object is equal to K times X. Okay, you see K is given here and X is given here. It is equal to how much? 0.3 meters. You see here it is centimeter, we should convert into meter because here unit is meter and here it is Newton by meter. Everything should be in SI system. Now mass we do not know. G, you know, 10 Newton per kg equal to K, you know, here it is given 200 Newton per meter. X unit is given 0.3 meters. Okay, you see here common factors we can cancel. Meter can be cancelled. Okay, next kilogram, sorry, Newton can be cancelled. The remaining terms, here we have 10, here we have 200 times 3. Okay, this side will be 200 times 3 will be 60, will be equal to this side 10 into mass, okay, divided by kilogram. If we divide both sides by 10, then mass divided by kilogram is equal to 10. So it's 6, right? Now if we do cross product this way, if we do cross product down, here we will get mass is equal to 6 kilogram. This is how we calculate the mass of a given object. Potential energy of a spring. You know, if we do work on a spring, that work done will be stored as a potential energy in the spring. For example, if we stretch this object by applying this amount of force, it means if we apply force and make some displacement, if force is there, displacement is there, then there is work done, and that work done will be stored as potential energy in this spring. Now, how do we calculate this potential energy in the spring? Okay, we just use one simple formula. This formula we use, this formula is used to calculate this potential energy of a spring. Okay, what is potential energy of spring? Potential energy of a spring is the work done on the spring. That work done will be stored as potential energy. Now that potential energy is equal to area in this graph will be equal to work done equal to K times x square divided by 2. Okay, K you know spring constant, x you know magnitude of stretch. Okay, so we use this simple formula to calculate potential energy of a spring. You see here, potential energy of a spring is equal to work done on the spring equal to 1 over 2 into kx square. You know unit of energy is joule or kilojoule. Okay. Example number 7. Example number 7. A block is attached to a spring with a force constant of this minus shows 200 Newton the decrease in potential energy. Spring constant. This spring is compressed at a distance of conservation of mechanical energy. Okay. From its equilibrium position and release. This says that first mechanical energy is always released. Okay. Find first of all. We should find the work done by the applied force. How much work will be done by this external force? Next, B part, we should find the work done by the spring force. Means work done by restoring force of spring itself. Next, the total work done on the spring. Okay, total work done on the spring will be how much? Okay, let's solve first of all A part. You know, work done is equal to potential energy of spring equal to 1 over 2 potential energy of the spring equal to 1 over 2 kx square. Okay, Now from here, work done is equal to 1 over 2 into K. K is 200 Newton by meter into X here is 20 centimeter, as you see here. 20 centimeter means 0.2 meter. 0.2 meter square. From here, this 2 with this 2 cancel, and here 100 left. 100 Newton divided by meter into 0.2 meter whole square will be 0.04 meter square. Here meter 1 meter cancel, 1 meter here left. Okay, and if you multiply 100 by 0.04, it becomes 4 only. 4. And the Newton times 1 meter will be joule. 4 joule work is done by this external applied force. Let's take this external work done by this external force as positive. Okay, positive 4 joule has been done by this applied force. Next, B part, the work done by the spring force. Now I erase the board and solve B part. Okay, we should remember that work done by external force is 4 joule. Okay, B part. We have taken the work done by external force as positive. Now spring will do work against that force. Now let's take this work done by as negative. Work done by spring itself, let's take it as minus 1 over 2 kx square. Okay, work done is equal to minus 1 over 2 into 200 Newton per meter times 0.2 meter whole square, and finally work done is equal to minus 4 joules. Okay, it means spring is working against applied force. C part. Okay, C. Applied force does work this side, and spring does some work against this. It means they are doing work against each other. Then finally the total work done on the spring will be 4 joules minus 4 joules equal to 0 joules. Example number 8. A spring has a spring constant 400 Newton per meter. How much this spring should be compressed to store 800 joule of energy? Okay, you see K is given, amount of work done or potential energy is given. Here we have to calculate amount of compress. Okay, solution. We know potential energy of spring is equal to work done equal to 1 over 2 K into X square. You see this is given here, this 800. Then 800 joule means Newton times meter equal to 1 over 2 times K is 400 Newton divided by meter into x square. Okay, from here let's do cross product. 2 times 8 will be 1600 Newton meter is equal to 400 Newton divided by meter into x square. Okay, now let's divide both sides by 400. Okay, if we divide both sides by 400, then 4 meter here, 1 meter here we have, you see, 1 meter here we have. If you multiply with this meter, it becomes 4 meter square is equal to x square. If we take under root 2 both sides, then 2 meter is equal to x. This is how we calculate the amount of compression. Okay, next. Power. What is power? Power is the amount of work done per unit of time or amount of energy spent per unit of time. Okay, power is defined as the amount of work done per unit of time or amount of energy spent per unit of time. So power is equal to work done divided by time. What we said in definition, it is work done per unit of time. Okay, so power is equal to work divided by time. What is the unit of work? Unit of work is joule. What is the unit of time? Unit of time is second. Okay, then the unit of power will be watt. Okay, unit of power will be watt. Obviously there will be large units also, like kilowatt. 1 kilowatt is equal to 1000 watt. Next, for example, horsepower is there. 1 horsepower is equal to 746 watt. Okay, here we can have different formulas, different cases of formulas, you can say, like force time displacement divided by time. You know, distance divided by time is velocity, right? Then force time velocity also will be power. Now let's solve some examples. An engine exerts a force of 200 Newton on a rope and pulls it a distance of 72 meters. In how much time? In 0.05 hours. What is the power supplied by the engine? Okay, one engine we have, and that applies a force of 200 Newton and pulls it by 72 meters within 0.05 hours. Okay, let's solve it. You know, power is equal to work done divided by time, and from here work, you know, force into displacement divided by time. Okay, let's write the given values. Force is 200 Newton times x is how much? 72 meters. 72 meters divided by t is 0.05 hours, means 0.05 into 60 seconds. Okay, and it is equal to 2 times 2 4, 2 times 7 14, 100 Newton times meter, joule divided by, If we multiply this 0.05 into 60 into 60, it becomes how much? 0.05 into 60 into 60, 180. 180 unit is second. Okay, and this one will be equal to how much? 14,400 divided by 180. 14,000, it is 80, and joule divided by second is watt. And this is how we calculate the power of engines or some other objects. Okay, efficiency. Efficiency is a parameter which is used for determining the usefulness of one machine or a system. Okay, so efficiency shows the usefulness or the effectiveness of one object or one machine. How we can calculate, how we can determine the efficiency. Okay, efficiency is equal to energy output divided by energy input is efficiency. Okay, but what is energy output, energy input? Let's take the example of generators. To get electricity, what do? We just give petrol energy to generators. Now petrol energy is input energy, and the electrical energy which we get from generator is output energy. Okay, or we can calculate in another way also, power output divided by power input. Okay, now the efficiency of systems or machines always smaller than 1. Okay, smaller than 1 means it is smaller than 100%. It can never be 100%. Okay, now efficiency in percentage is equal to efficiency into 100. Efficiency means this ratio. Okay, output energy divided by input energy. Let's solve one example. Example 10. If 1000 watt of electric power is needed to work the engine, find the efficiency of engine in example 9. Okay, we solved example number 9, right? There we calculated the power as 80, right? Power we obtained as 80 watt. Now here we have to calculate efficiency of that engine. Efficiency of engine is equal to output divided by input. Okay, you see this much of power is needed. We have to give this much of power. So this is input power. Input is always in denominator. It is 1000 watt. And output is 80 watt, right? Into 100. And finally it becomes how much? Equal to 8%. Okay, I hope it's clear. Thank you so much.